In this section, we're going to talk about Hsrp protocol. A first-hop redundancy protocol, Hsrp, is a computer networking protocol which is designed to protect the default gateway used on a subnetwork by allowing two or more routers to provide backup for the address. In the event of a failure of an active router, the backup router will take over the address, usually within a few seconds. In practice, such protocols can also be used to protect other services operating on a single IP address, not just routers. Hot Standby Router Protocol, Hsrp, is a routing protocol that allows host computers on the internet to use multiple routers that act as a single virtual router, maintaining the connectivity even if the first hop router fails, because other routers are on standby and they are ready to go. Virtual IP and MAC addresses are shared between the two routers, and there is no load balancing and verified by the show standby command. As you can see that in our figure we have two routers, and they are router 1 and router 2. And please pay attention that I'm using Hsrp to protect the default gateway for here and here. If there's a problem in that router's this interface, or if that router fails completely, for example, we can have an power unit problem, or we can have a cable problem in the interface connecting between switch and the router. If this router is the active one, the Hsrp protocol will switch the traffic to the standby router. This is actually what Hsrp is doing, but there is no load balancing, as I said. For example, if this one is the active router, router 1 is the active router, the traffic flows in that direction and there is no packet in here. When this guy fails, the traffic is switched to this direction. And if I configure preemption on router 1, for example, let's say that I have fixed the power unit problem, and if I configure the preemption as well, this router will become the active gateway again, and this guy will act as a standby. So let's take a look how we select the active and the standby gateways in the Hsrp. As you can see that in the figure we have two routers again, and the router with the highest IP address will be active by default. But the selection can be changed with the Hsrp priority value. The router with the highest Hsrp priority value becomes active, and default priority value is 100. The active and the standby routers send the hello packets to the Hsrp group multicast address in 3 seconds. If the hello packet does not arrive in 10 seconds, the standby router becomes active. Okay, let's say that this guy is active again and this guy is standby. If I want to change the roles, if I want to make this guy as an active, I need to increase the priority value of this router. When I increase the priority value, this guy will be active and traffic will flow in this direction instead of this direction. In Hsrp, the active gateway propagates this MAC address and says that, hey guys, use this MAC address, which XX is the Hsrp group identifier, to reach this IP address, which is Hsrp standby IP. Let's talk about the topology now. We have a PC in here which has an IP address of 10.100. The gateway address of the PC is 10.1, and please pay attention that that's the Hsrp IP. So I'm going to attach this IP address to this interface of the router 1, and I'm going to attach this IP address to this interface of router 2, and I'm going to attach a standby IP for both of them, and that's going to be 10.1, and I'm going to define the gateway as 10.1. So what do you think about this? For example, why I'm not attaching the 10.2 as gateway? Let's say that the gateway is 10.2. If the gateway would be 10.2, I would follow this line to send the packets to wide array network, right? But when this router fails, if there's a problem with this router in the network, because of the 10.2 will fail also, I wouldn't go to wide array network. But if I configure this one, whenever this router fails, router 2 will be the active router and take the traffic onto it, and I'm gonna reach the wide array network again without any interruption. Let's take a look to the Hsrp preemption feature. If the active router fails, the standby router is activated and it remains active even if the previous active router is returned. Preemption process forces routers to a new Hsrp selection. And here are the states of the Hsrp routers. We have six states, and the first state is initial. This is the beginning state. It indicates Hsrp is not running. It happens when the configuration changes or the interface is first turned on. In the learn state, the router has not determined the virtual IP address and has not yet seen an authenticated hello message from the active router. In this state, the router will still wait to hear from the active router. In the listen state, the router knows both IP and MAC addresses of the virtual router, but it's not the active or standby. In the speak state, the router sends periodic Hsrp hellos and participates in the election of active or standby router. In the standby state, the router monitors hello packets from the active router, and it will take the active state when the current active router fails. And in the active state, the router forwards packets that are sent to the Hsrp group. The router also sends periodic hello messages. And here is the configuration of the Hsrp. First, I need to fix the IP addresses for my configuration. The IP address in here is 30.2 and here is 30.3, and my gateway is 30.1, and my Hsrp is also. What I do in the configuration is I'm going under the interface mode and I'm assigning the IP addresses at 30.2 and 30.3 to the physical interfaces. These are for here and for here. Then I'm gonna attach the standby IP by using standby and standby group number and IP and the IP address. Okay, I'm doing the same thing on router 2. I just have two different configurations for router 1 in here. Standby 1 priority 150. This line shows me that router 1 is the active router for this Hsrp topology. Because of the default value of the priority is 100, if I choose the 150, this guy will be the active one. And here, as you can see that I type standby 1 preempt command, which means I have configured the preemption. For example, if this router fails, this guy will be the active one. But when this router is back, this guy will be standby again and router 1 will be active because I configured the preemption. To verify the Hsrp configuration, I'm using the show standby command and I can see the group number, state, active virtual MAC address and standby router's IP as well by typing the show standby command. I can use different gateways for different VLANs in Hsrp2, and this is what multigroup Hsrp is doing for me. For example, for VLAN 10 and VLAN 20, I'm using this guy as primary and I'm using this guy as the secondary for VLAN 20 and VLAN 10. Then I'm getting under the interface VLAN, for example, interface VLAN 10, I'm attaching a lower priority for VLAN 10 and higher priority for VLAN 20, which means this is gonna be active for VLAN 20 and this is gonna be in standby mode for the VLAN 10. Hsrp has another great feature that is known as Hsrp interface tracking. As I told you in the first slide, Hsrp always is responsible for protecting the default gateway, these interfaces. But when I try to connect to internet, I have also these interfaces as well. So what Hsrp is doing with interface tracking, Hsrp is watching that if this interface is up or not. If this interface fails, for example, if serial 00 interface fails, what Hsrp is doing, this is decrementing the priority value of router 1 and router B is becoming the active router, so I'm not having an interruption, so traffic is flowing in this direction. So another thing that Hsrp can do is object tracking. For example, let's say that I have no problem in this interface too, and everything is okay in my local area network. Here is my local area network. My router is working fine and there's no problem in this interface or this interface. Everything is okay, but there may be a problem on the ISP network. Maybe I have a central router in here that I'm collecting the traffic from the branch offices. What Hsrp object tracking does, I can ping here this interface of my HQ router, and if ping fails to the HQ router, I can change the traffic's pattern again and maybe I can use another ISP and another central router, and so that my traffic won't interrupt. Here's the object traffic configuration as well. I'm defining an IP SLA, and I'm trying to ping this IP address. As you can see that I have a local area network switch and I have router 1 and router 2, and on the other side I have a core router which has an IP address of 1.1. Then I'm defining a frequency, which means that I'm gonna ping here each 5 seconds. Then I'm defining the start and the finish time of the IP SLA. Then I'm tracking this IP SLA, and whenever there's a problem, I'm gonna decrement the priority value and the other router will switch as a active. Hsrp provides the following two types of authentication, and they are plain text and the MD5. If you want to configure a MD5, you can use the standby group authentication, MD5 keystring, and the keystring number and the string. The group number is arbitrary. You can choose anything that you want. If you want to configure a plain text, you can use standby, for example, 1 authentication, and you can use the string that you want. All routers in a Hsrp group send hello packets. By default, the hello timer is set to 3 seconds and the dead timer is set to 10 seconds. It means that a hello packet is sent between the Hsrp standby group devices every 3 seconds, and the standby device becomes active when a hello packet has not been received for 10 seconds. If you want to modify the hello and hold time timer, you can use standby group number, timers, and hello time or hold time command. There are two versions of the Hsrp, and they are version 1 and the version 2. Version 1 is the default version of the protocol. Hsrp version 2 allows group numbers up to 4096, thus allowing you to use VLAN number as the group number. All devices in an Hsrp group must have the same version configured, otherwise the hello messages are not understood.